Question number 6. Square root of 1 plus sin a divided by 1 minus sin a equal to secant a plus tan a. So on LHS we have sin and on RHS we have secant a and tan a. So our intention should be to eliminate this sign. In place of sin we should get a secant and tan. First consider the LHS. LHS equal to square root of 1 plus sin a divided by 1 minus sin a. Multiplying and dividing by 1 plus sin a inside the square root. In the numerator it is same as a plus b into a plus b. Therefore it is a plus b whole square divided by, in the denominator it is same as a minus b into a plus b. Therefore a square minus b square, all under square root. Square root cancels, we will get 1 plus sin a divided by 1 square minus sin square a. 1 square is 1, 1 minus sin square a is cos square a, square root cos square a. 1 plus sin a divided by square root square cancels, we will get cos a. Separate the denominator, 1 divided by cos a plus sin a divided by cos a. 1 divided by cos a is secant a, sin a divided by cos a is tan a, which is RHS. Question number 7. Secant square sin theta minus 2 sin cube theta divided by 2 cos cube theta minus cos theta equal to tan theta. Consider LHS. Sin theta minus 2 sin cube theta divided by 2 cos cube theta minus cos theta. Sin theta is common in the numerator, 1 minus 2 sin square theta divided by cos theta is common in the denominator, 2 cos square theta minus 1. Sin theta into 1 minus 2 sin square theta as it is divided by cos theta. 2 as it is, cos square theta can be written as 1 minus sin square theta minus 1 by using the first identity, that is sin square theta plus cos square theta is equal to 1. Therefore cos square theta is 1 minus sin square theta. Sin theta into bracket 1 minus 2 sin square theta divided by cos theta into 2 ones are 2 minus 2 sin square theta minus 1. Sin theta into 1 minus 2 sin square theta divided by cos theta as it is into 2 minus 1 is 1 minus 2 sin square theta. 1 minus 2 sin square theta divided by 1 minus 2 sin square theta cancels. Remaining thing is sin theta in the numerator and cos theta in the denominator. Sin theta divided by cos theta is tan theta, which is equals to RHS. Question number 8. So we have sin a plus cosecant a whole square plus cos a plus secant a whole square equal to 7 plus tan square a plus cot square a. Consider the LHS sin A plus cosecant A square plus cos A plus secant A whole square. Apply the A plus B whole square identity. We will get sin square A plus cosecant square A plus 2 sin A into cosecant A plus here A plus B whole square cos square A plus secant square A plus 2 into cos A into secant A. So what happens? Sin square A plus cos square A equal to 1 plus sin A cosecant A cancels with 2 remains 2 into 1 plus here cos A cancels with secant A, so 2 into 1 plus cosecant square A plus secant square A as it is. This equals to 1 plus 2 plus 2 plus cosecant square A can be written as 1 plus cot square A. Similarly, plus secant square A can be written as 1 plus tan square A using the identities. This is equals to 1 plus 2 plus 2 plus 1 plus 1, it is 7 plus cot square A plus tan square A, which is equals to RHS. So 7 plus tan square A plus cot square A. Question number 9. Cosecant A minus sin A into secant A minus cos A equal to 1 divided by tan A plus cot A. Consider LHS cosecant A minus sin A into secant A minus cos A. Cosecant A is 1 divided by sin A minus sin A. This is 1 divided by cos A minus cos A as it is. LCM sin A. So numerator is 1 minus sin square A. Here LCM is cos A, 1 minus cos square A. 1 minus sin square A, it is cos square A divided by sin A as it is into 1 minus cos square A is sin square A divided by cos A as it is. So 1 sin cancels with sin A, 1 cos A cancels with cos A. Remaining is cos A into sin A. Let us call it as equation 1. Consider the RHS (1 divided by tan A plus cot A). This equals to 1 divided by sin A divided by cos A plus cos A divided by sin A. This is equals to in the denominator LCM is cos A into sin A. Sin A into sin A is sin square A plus cos A into cos A is cos square A. This is equals to, this cos A into sin A comes to the numerator and multiplies with 1. So we will get cos A into sin A divided by sin square A plus cos square A is 1. So this is equals to cos A into sin A, equation 2. From equation 1 and equation 2, you can observe that both are cos A into sin A. Therefore, LHS is equal to RHS. Last question in this exercise, 1 plus tan square A divided by 1 plus cot square A equal to 1 minus tan A divided by 1 minus cot A whole square equal to tan square A. Consider the LHS part, 1 plus tan square A divided by 1 plus cot square A. 1 plus tan square A can be written as sin square A divided by cos square A whole divided by 1 plus cos square A divided by sin square A. This is equals to, LCM is cos square A here. So cos square A plus sin square A whole divided by sin square A plus cos square A whole divided by sin square A. Cos square A plus sin square A is 1. Sin square A plus cos square A is also 1. So what we will get? 1 divided by cos square A divided by 1 divided by sin square A. This is equals to sin square A divided by cos square A, which is equals to tan square A. This is equals to RHS. Consider the other part, 1 minus tan A divided by 1 minus cot A whole square. Here, separate the square to the numerator and denominator. We will get 1 minus tan A whole square divided by 1 minus cot A whole square. Apply the identity A minus B whole square. A square plus B square minus 2 into 1 is 2, 2AB divided by A square plus B square minus 2 1s are 2 into cot A. This is equals to 1 plus tan square A minus 2 tan A divided by 1 plus cot square A minus 2 cot A. One plus tan square A is secant square A from the identity minus 2 tan A divided by, this is 1 plus cot square A from identity, it can be written as cosecant square A minus 2 cot A as it is. This is equals to, secant square A is 1 divided by cos square A minus 2 into sin A divided by cos A whole divided by 1 divided by sin square A minus 2 into cos A divided by sin A. This is equals to, here cos square A is LCM, so cos A minus, 1 minus 2 sin A cos A divided by sin square A is LCM here, 1 minus 2 cos A to sin A. 1 minus 2 sin A cos A cancels with 1 minus 2 cos A sin A. Remaining thing will be 1 divided by cos square A divided by 1 divided by sin square A. This is equals to sin square A divided by cos square A. This is again equal to tan square A, which is RHS. So this is the answer. You can solve this one in other way also. 1 minus sin A divided by cos A divided by 1 minus cos A divided by sin A whole square. In the numerator, cos A is LCM. Cos A minus sin A whole divided by sin A is LCM in the numerator. Sin A minus cos A whole square. This is equals to, take negative sign common in the numerator, it becomes sin A minus cos A divided by cos A whole divided by sin A minus cos A divided by sin A. This is square. So we took negative common, so minus sin A becomes plus sin A, plus of cos A becomes minus cos A. In the bracket, sin A minus cos A cancels with sin A minus cos A. So we will remain with minus 1 divided by cos A divided by 1 divided by sin A. This square. Negative square is positive. Sin A divided by cos A whole square. Sin A divided by cos A is tan A and its square is tan square A. So which is RHS. So this is completion of the exercise 11.4.